Good morning, friends. Today I'm gonna give you a lecture on design a singly reinforced beam. So the question is hereby design a simply supported singly reinforced beam of having a clear span of 5 meter to support a working load of 25 kN per meter a run. Use Fe415 grade of steel and M20 grade of concrete. Assume the support thickness as 230 mm, that is the bearing. So this is our question, and now we are having the given materials which we had get from this question, and those are the given material. This is our simply supported beam. This is our beam which is having a superimposed load or a live load of 25 kN per meter and having a clear span of 5 meter, and it's having a bearing or the thickness of the support is 230 mm. Now the working load, that is the live load, that is 25 kN per meter, and we are here also given that in the above case, that is here is two Fe415 steel is given and M20 grade of concrete is given. So for this reason the value of Fy is equals to 450 Newton per mm square for Fe415 and FCK value is 20 Newton per mm square at M20 for M20 grade of concrete. Now we are starting the design. For this starting the design, we are having the first of all step is that step one we are having two parts. That is, first part is fixing up the depth of the section, for which we would be needing a depth, that is the effective depth, for which we are for fixing up the depth of section we are getting here to the deflection control criteria, which is given in our IS Indian Standard Code in 456 2000 clause number 23.2.1 page number 837. For a simply supported beam, it is given that the L by D ratio, that is effective span by effective the effective length by effective depth ratio is equals to 20 for span up to 10 meter, and we are having a span of 5 meter, that is it is in between 0 to 10, so that's why we are using this L by D ratio as 20. And the effective depth ratio, we will calculate that, evaluate this value, we would get D, that is small d is equals to capital L by 20. That would give us the effective depth value is equals to 250 mm. Now we are providing a cover. It is the normal cover which is 25 mm. So if we give a cover of 25 mm, we will get the overall depth of the beam as 250 mm plus 25 mm, that is 275 mm. The dimension of the section would be assumed as the width of this beam is 230 mm and effective depth as 250 mm. Now the second part of this first step is the check for lateral stability or lateral buckling. For checking the slenderness limit for beam to ensure lateral stability, we would require we would recommend a code, that is Indian Standard 456 2000 clause number 23.3 page number 39. For simply supported beam, the clear distance between the lateral restraints, that is allowable A, which we had assumed here, doesn't exceed 60b or 250b square by d, whichever is less in both of these two values. So first of all, we are taking the 60b, which is giving us 13.8 meter, and the second which we are taking is 250b square by d, that is we are given that 52.9 meter. So therefore the lesser value of these things, which would be going to be the allowable L, that is 13.8 meter. Now for checking that the clear span is taken okay with respect to the dimensions, so we would check one thing, that is allowable L of the beam, that is the actual L which is given to us, that is 5 meter, and the allowable L which is 13.8 meter. The actual L should be lesser than the allowable L, then this would be okay. That means our lateral stability, lateral buckling check is satisfied for this design. The next step is we are going to calculate the effective span of the beam. So for calculating the effective span of a beam that is simply supported, we are recommended as for IS 456 2000 clause number 22.2 part A, that is page number in 34. That's we are having two values, that is the effective length having two values, and whichever is less we would take it as effective length. The first one is clear span plus effective depth, that would be giving 5.25 meter, and another one is clear span plus half of bearing plus half of bearing, that would be giving us 5.23 meter. Now whichever the less of the both two values would be taken as LE, that is effective span value, that is 5.23 meter. Now the third step is calculation of loads, that is consider 1 meter length of the beam and we are having a self weight of the beam. How to calculate the self weight of the beam? For calculating the self weight of the beam, we would have to calculate a formula, that is B into capital D into L, which is in meter for 1 meter, which we had considered, and 25 kilonewton per meter, that is the gamma, that is the unit of the concrete, unit weight of concrete we are taking here. So the self weight of the beam we are getting here, that is 1.58 kilonewton per meter. And the second one, which is given that working load or the live load, that is 25 kilonewton per meter. The total load, that is W, we are considering here, that addition of these two things, we would get 26.58 kilonewton per meter. And the factor load we have to calculate. For calculating the factor load, we would first of all calculate the thing is that we are calculating total load into factor of safety, that is partial safety factor. That is, we are taking here the partial safety factor for load is 1.5. So we are getting that 39.87 kilonewton per meter, that is we are equivalent this value to 40 kilonewton per meter. And next one is we have to calculate the factored moment, that is mu, which is giving that WU L is square by 8. So from this formula we are getting this 136.76 kilonewton per meter, and factored shear VU is equal to WU L E by 2, that is we are getting that 104.6 kilonewton.